This is your teacher Jenny again. Join me for another video. This time we are going to discuss or talk about hyperbola on its parts using graphing method. Let's start with the first example. We have our hyperbola equation x minus 1 squared over 9 minus y plus 4 squared over 16 equal to 1. Now notice if you are dealing with hyperbola, you are going to check the equation first on what on the expression of your equation is positive. Is it gonna be with the x or with the y? So if you try to look at the equation here, the one which got a positive expression is on our x, because if you try to look at here, before y we've got a minus, so literally the positive expression here is with the x here. So since that is a positive expression, automatically we will be identifying the orientation of our hyperbola as horizontal. So again, the orientation of the hyperbola will be basing on whatever variable is with a positive expression. So since we already know the orientation as horizontal, we will be identifying first our A, our B, and our C, so that we can identify the different or the rest of our parts of the hyperbola. So let's start with identifying our A. So unlike our ellipse, wherein we are identifying the A based on the bigger denominator, in hyperbola it's different, because you will be basing your A to whatever variable or to whatever positive expression you have in your equation. So this time we have here 9, which is with a positive expression. So basically this is our A squared. So since this is our A squared, we get the square root of 9. That will be our A, which is equal to 3. And so if this is our A squared, this one here with the negative expression is our B squared. So since B squared is 16, getting the square root of that one, that is equal to 4. So what is A? What is B? Our A is the distance from the center to a vertex. And our B is the distance from our center to a co-vertex, and our C, this is the distance from the center to a focus. So we will be identifying our C using the formula C squared equal to A squared plus B squared. So this is different from the ellipse, wherein you've got a minus in there. For hyperbola, we will be adding A squared and B squared. So to get the C, we just get the square root of that. So we have the square root of A squared plus B squared, and then plugging in plugging the information or the values, we do not use this one because we will be repeating the process wherein we're squaring our A and our B. So we just refer to our A squared here, which is 9. So we've got square root of 9 plus B squared, which is 16. So we've got that one as 16. So our C here will be equal to the square root of 9 plus 16, that is 25, and the value for C here is 5. So since we have now A, B, C, we are now ready to identify our parts of our hyperbola. So let's start with the center. The center here, we will be identifying that one based on the equation that we've got. So the center here is gonna be with H and K, wherein we've got this one as our H, this one as our K. So writing that one as the center here, we have, this is -1, so automatically this will be our 1. Positive 1 on X, and then our Y here is with +4, so our K will become -4. So this will be our center. Now, since we are using graphical method in identifying the different parts of the hyperbola, so we will be plotting that one here, the center. Once we have the center already, we are going to plot that one here on our graph. So we have 1, -4. So 1 on x is here, which is positive. Negative 4 is here on y. So this will be our center. So once we're done with the center, we are going to identify now our other parts. Now the other parts, we've got the vertex or the vertices. So since this is hyperbola, we will have two vertex here. Now the vertex will always be associated with our A. So whatever you've got there as a value of A, we will be using that one to spot or to locate our vertex. So since we have here our A is 3, so we will be moving. This is horizontal orientation. So we will be moving horizontally from the center 3 units to the right and left. So we have here center is here. We have 1, 2, 3. This will be our first vertex. So this is vertex 1. You can name that one as vertex 1. You can name that one as vertex 2. So let me just name that one as vertex 2 from left to right. Next one, we will be locating our other vertex. So we count again from the center to the left. We have 1, 2, and then 3. This will be where our vertex 1 is located. So we have now the values of our vertices. So we are going to name the coordinates of that one. So we have here vertex 1. We have that under negative 2. So we have negative 2 on x. And then we have that one here as negative 4 on y. And then we have the other vertex here is with 4 on x. And then we have our negative 4 on y. So those are our vertices. Now next one, we are going to identify our covertices. So covertices will be related with B. So whatever value of B there, we are going to identify that one here or count from the center towards the covertex. So that is how we locate that one. So since B is 4, we will be counting from the center 4 units up and down. So we have here 1, 2, 3, 4. This is where our covertex is. So let me just have it as or I'm not gonna label that one. So anyways, we've got a center here. We count 4 units as well down. So from the center, we have 1, 2, 3, and 4. This is where our other covertex is. Now, writing now our coordinate of those covertices, we are now going to start with the upper one. Regardless of where you start with, it's really fine as long as you have given the correct coordinate of the covertices. So the first one from the top, we got that one as our x value there is 1. And then our y value is 0 because it lies on the x-axis. Next one, we have the bottom covertex there is on 1 on the x value. And then we've got this one is negative 8. From here, we've got negative 6, negative 7, negative 8. That is negative 8. So those are our covertices. So once we're done with the covertex and the covertices, we are going to identify our equation for the asymptote. Now, before that one, we are going to first identify our foci. So first, we've got a foci here. Now, the foci will be located innermost of our graph. So locating that, innermost of our opening of the graph. So locating that one, will be utilizing our C there. So from the graph, our C is 5. So from the center, take note, the foci will also be located where your vertices are. So if your vertices are horizontally related, then that means to say that the foci is also horizontally related. So from the center again, we have to count. So from the vertex, from the center, again, we will be counting 5 units to the left and right. So we have 1, 2, 3, 4, and 5. This is where our foci is. I'm naming that one as F1. And from the center, again, we're going to count 5 units to the right. So we have 1, 2, 3, 4, and then 5. This is where our foci 2 is located. So we're now done with the plotting of the foci, the covertices, and the vertices. So let me just first identify the coordinate of the foci. So we have here, first foci, we've got -4 on x, and then we have -4 on y. The other focus here, we've got 6 on x and then -4 on y. So those are the coordinates of the foci. Now, going back to the graph, we are going to draw. Once we are graphing our hyperbola, we will be drawing the rectangular reference or the reference rectangle, in which we will be drawing that one using the intersection of the vertices or the line segment that passes through the vertices and the covertices. So here, this will be a line. Let me just use another color. So this will be a line passing through our vertices, vertex 1, and I will be also drawing a line, a broken line here passing through our covertex, and another line passing through our other vertex, and another line passing through our other covertex. So that is our reference rectangle. Now, out from the reference rectangle, we will be drawing broken lines for the diagonals. So, drawing that one here, connecting this one here of the rectangle, and passing through the center, and then connecting the other edge or the corner of the rectangle. This is what we have as, let me just extend. This is what I have as my asymptote line. So here, asymptotic line, sorry on that one. So here, I'll be also drawing a line passing through the center and the edge of that rectangle. This will be my guide for drawing my graph. So how do I draw the graph? The graph there will be drawn, let me use black, will be drawn based on the vertex here. So we will be drawing this one, the opening here, we'll be drawing that one based on this one here, the asymptote line or asymptotic line. And then here we will also be drawing that one. Notice that I'm not passing through with that asymptotic line there, because again, asymptotic would mean it will be approaching but never touching that one. So here, for the other vertex, I'm going to draw, although my line there might not be perfect, but if you try to look at that one, I'm trying. Okay. So here, I'll be also drawing another graph. And also here, I will be approaching that yellow broken line. So this is where, or this is how our parabola looks like, hyperbola looks like when you graph that one. Now, once you're done, after graphing that one, we can simply identify our equation of that asymptotic line. We need that one. So we will be identifying our equation of that asymptotic line or asymptote, in which that will be using the formula, which is y. Since this is horizontal, y is equal to k and then plus minus b over a times x minus h. So simply plugging in, so we have here y is equal to our k there based on our center. We have this one as our h and k. Our k there is -4. We have that as plus minus. Our b is 4. and our a there is 3, and then times x minus our h there is 1. So this will be our equation of that asymptotic line or line asymptote line. So you may try to break this one apart by simply writing here y is equal to negative 4 plus 4 over 3 times x minus 1, wherein 4/3 here is our slope of the line. Another one here is y equal to negative 4 minus 4/3 times x minus 1. So those will be our equation of the line which is asymptotic to that graph. Now next one, once we're done with the asymptote, we are going to identify our principal axis. Now the principal axis here, because that is horizontal in as the orientation of our hyperbola, our principal axis, we have that one as this. The principal axis, take note, passes through, is a line that passes through the focus, the vertex, and the center. So this one is our principal axis, and that one is gonna be y equal to so principal axis is y is equal to our k, y which is equal to k there is negative 4. So this is our principal axis. Now if we are going to look for the length of the transverse axis, so length of transverse axis, take note the length of the transverse axis is equal to 2a. 2a, this is, since we've got a there as 3, so 2 times 3, that is equal to 6. That is the length of the transverse axis. So let us now identify the length of the conjugate axis. So let me just write it here. So the length of conjugate axis. When we say length of the conjugate axis, this refers to the length of the line segment connecting the two co-vertices. So we are referring to our 2b. So the length of the conjugate axis will be 2 times our b is 4. That will be equal to 8. So that's the length of the conjugate axis. The length of the foci, that will be now equivalent to 2c, in which that is 2 times 5, which is 10. So we've got now the different parts of our hyperbola. And let us now have another example. So the next example here is this one, wherein we have y plus 3 squared over 36 minus x plus 5 squared over 36 equal to 1. So if you try to look at this, we've got our hyperbola in which our positive expression is on the y. We have here y here which is positive, because if you try to look at here the x, before that one is a minus, so literally we've got a negative expression on x here. So since that is on y, so the orientation here is vertical because it's on y. Now, since we have the vertical orientation, take note our standard equation for that vertical oriented hyperbola is y minus k squared over a squared still minus x minus h squared over b squared equal to 1. So that's our standard equation. Now, a, we will be identifying a, and please take note our a squared will always be on the positive expression. So this one is our a squared. This one is our b squared. Although they have the same value, that is really okay when it comes to hyperbola. So we have now our a, square root of 36, that will be 6. Our b, square root of 36, that will be 6. So let's go for c. Our c will be determined through C equal to square root of A squared plus B squared, coming from C squared equal to A squared plus B squared. So plugging in, square root of A squared, our A squared here is 36. Our B squared is 36. So we've got that one as C equal to square root of 72. In which that is equivalent to 8.49. So our C there is 8.49. So since we have now the C, we are now ready to have our center. Our center here is, we have here on X, which is positive 5. So that will become negative 5 here on the center. And our Y here is with plus 3. So that will become negative 3 here on the center. So we have now the center here. Now, since this is a graphical method, I'll be plotting that one here. The center here is on negative 5. This is negative 5 on X. Negative 3 is on negative 1, 2, 3 here. So this is where our center is. So we will be locating now the different parts in which we have there the vertices. So the vertices will be locating that one on the graph by simply counting the number of units from the center going to our vertex. Now, since this is vertically oriented, we will be counting from the center to the vertex upward and downward. So we have here from C, we count 6 units. So we have 1, 2, 3, 4, 5, 6. This will be our vertex 1. Next, we will be counting 6 units as well from the center going down. So we have 1, 2, 3, 4, 5, and 6. So this will be our vertex 2. So identifying now the coordinates of the vertices. So we have here the vertex 1. We've got that from negative 5. And then we have that one on 3 on the y-axis. And then the other one is with negative 5 on X. And then we have 9 on the y-axis. So next one, we are going to identify our co-vertices. So again, we'll be using graphical method. So from the center, we will be counting horizontally 6 units as well because our B there is 6. So we have 1, 2, 3, 4, 5, 6. This will be our co-vertex. And then 6 also to the left side. 1, 2, 3, 4, 5, and 6. So identifying now the coordinates of the co-vertices. So we start with, from the left side, we have that one as negative 11. And then we have on Y here as negative 3. And then we also have 1 and then negative 3 on the right side. So next one, we are going to identify the foci. The foci here, if we are going to count from the center to see towards the focus, 8.49 units. This will be towards where the opening or towards where the vertices are. So we will be counting from the center 8.49 units. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then 0.49 might be somewhere here. This is our focus 1. And downward, we have 1, 2, 3, 4, 5, 6, 7, 8. And then 0.49 might be somewhere here. So sorry on that one. It passes through the Cartesian plane. So, I mean, it exceeds on the Cartesian plane. But anyways, let's try to assume that that one is part of the Cartesian plane. Now, next one, we are going to identify our coordinate of that one. So we have here, from the top, we have that as a negative 5 on X. And then Y value there is, since this is 5, and then we've got 0.49 there, so 5.49. So next one, we have negative 5. The bottom part there is on negative 11.59. So that will be our foci. So once we're done with the foci, let's now go for the principal axis. So principal axis, since this is vertical orientation, we will have there x equal to h. X here is equal to h on the center, which is -5. So if we are going to draw that one, we can clearly see that our principal axis there passes through our value on x, which is -5. Because again, your principal axis passes through the focus, the vertex, and as well as the center. So see, it passes through the value of your x there, which is equal to -5. So this will be our principal axis. So next one, we will be drawing the reference rectangle by simply drawing a line here passing through the vertex, and so with a co-vertex. You may draw that one using a broken line. Oops. And everything else. So this will be our rectangle. After that one, we will be drawing our diagonal of that rectangle that will serve as our line of asymptote. So this will be our diagonal. That will also pass through the center. And also this one here, passing through the center as well. So that will serve as our asymptote line. So next, we will be drawing our hyperbola. So from the vertex, we will be drawing approaching our the line, the asymptote line. Okay. And then here, we've got also the vertex. So let me just change my color so that everybody can see. So from the vertex, we are going to draw the graph here approaching to that line of asymptote. Okay, so there. Let me trace the other part. Okay, so there. That will serve as our graph for this hyperbola. Now, next one, we're not yet done because we have to identify first our equation of the asymptote. So since this is vertical, we are going to use the equation. So for the vertical orientation, so we have our equation for the line here as y equal to k minus or plus minus a over b times our x minus h. So this will be our equation of the line asymptotic to the graph. So plugging in, y will be equal to our k here on the center. We've got that as -3 plus minus. Our a here is 6, and then b is 6. And then we have x minus our h here is -5. So this will become a +5. So simplifying this one, this will be now, and breaking also, this is y equal to -3. We have plus 6 over 6, that's 1. So we have 1 times x plus 5, that is x plus 5. And then we can also try to simplify that one further. Let me just have the minus also here. So we can have it as y equal to -3 plus x plus 5. So this will be now y equal to x plus 2. This will be our equation. First equation. So next one, the other equation here is with y equal to -3 minus, since this is a minus, we are going to distribute the negativity here inside. So this will become -x minus 5. So simplifying that one, this is now y equal to -x, and then -3 minus 5, that's -8. So this is another equation of the asymptote. So next, we are going to identify the length of the transverse axis. So this is now 2a. So 2 times our a, which is 6. So we have that one as 12. And then we have the length of the conjugate axis. This is 2b. So we have 2 times 6. That will be 12 still. And then the length of the foci. This will be now 2 times 8.49. That will be 16.98. So those are the different parts of our hyperbola. So I hope that you learned something. Please practice and that will make you perfect.